Welcome to HEC Montréal Statistical Modeling class. So in this video, we'll see a bit of, we've already discussed model with independent observation, compound symmetry, AR1, and we'll see some more exotic choices in the catalog provided by SAS. So one way you could extend the AR1 we covered in the previous video is by allowing heterogeneous effects, right? So we could say, well, the variance at each time point is the same for all observations, so everyone has the same variability at time 1, but it changes from one time point to the next. Okay, so here, rather than have just one sigma square, I would have 5 variance parameters, sigma 1 square to sigma 5 square, and then you can see that the correlation is still rho, but then the covariance entries are now sigma 1, sigma 2 rho. Okay. And so this is the so-called autoregressive AR1 model. There's a similar model for compound symmetry, okay, the heterogeneous compound symmetry. That's really a sort of SAS notation. So similar thing, similar model. Of course, I can get back the AR1 model by setting all the variance parameters to be equal. Okay, so you can see here I've estimated 0.29, 0.39, 0.41, 0.48, 0.34. And so the correlation still decreases over time. Not much change for rho, 0.51, but now the variance seems to be a bit unequal. Okay, so this table of coefficients, you can see the 5 variance 1 to 5, and the ARH1, that's actually the correlation rho. Okay, which is comparable to the previous output. So you can see the estimated correlation, and what I'd like to say is, okay, well, that's fantastic, but how can I actually make sure that this model, which is more complicated, right, has 4 extra parameters for the variance, is significantly better than, say, the AR1 or the model in which there's no correlation. Okay, so SAS always has the likelihood ratio test for comparing this model to the model with a covariance matrix that's sigma squared times the identity. So here I can get from one to the other by fixing rho equals 0 and all the sigmas to be equal. And the p-value there is negligible. So I would rule out the independent observation assumption, and that's not surprising. We had the same results for the AR1 and the compound symmetry. There's overwhelming evidence of correlation between observations. Okay, I could also, so that's the ARH1. You could make a test to compare it to the AR1. We'll do this in a few moments. There's also other choice for the covariance, right? So here I have a 5 by 5 matrix. So I could say, well, I'm just going to not specify any model and estimate each of the parameters as free parameters. Okay, so this is a 5 by 5 matrix, has 25 entries, but note, because of the symmetry, sigma 1, 2 is sigma 2, 1, and so on. So really there's n times n plus 1 over 2 parameters. So this is 5 times 6 over 2. That's 15 parameters in total. Okay. So the AR1 model, that was very simple. There were 2 parameters, the variance and the correlation. I had 6 for the ARH1, and now I have 15 parameters. And recall, you're trying to estimate 15 parameters, and you have block replicates. Okay, and these block replicates, you only have 80 copies of them. And so you could specify the structure, but it's going to be highly uncertain. Okay, so unstructured model type equals UN. Well, there's you need to know. So variance, there's no specific thing. So estimated variance, actually, if you look at the estimated variance, they look a lot like the ARH output. Some entries are a bit lower, others are a bit bigger. Okay, so it seems like if you look at the correlation, now I have 0.59, 0.53, 0.54, 0.30. So you still see this kind of geometric decay, which could suggest that the AR1 is actually better than a compound symmetry, because there seems to be indeed a decrease in the correlation as observations are further apart. Okay, but this is sort of adduct. So this is the unstructured covariance parameters. You can see the entire list. So that's the entry 1, 1. That's the variance, okay, and the diagonal first element of the matrix. Then 2, 1, 2, 2, 3, 1, and so on. So you have the entire list of the 15 parameters. So every time you have I, that's a variance, and then the other ones are entries. So the second row, first column, or first row, second column would have a value of 0.21 for the covariance. Okay, and if you want to get the correlation, that would be 0.2165 divided by square root of 0.42 divided by square root of 0.31. Okay, so as before, you have always the output. Here we're comparing a model with 15 parameters to one in which there's only sigma squared times the identity. So of course they're nested. I can just fix all the off-diagonal entries to 0 and all the diagonal entries to be the same. That's 14 restrictions, and so I can see there's still overwhelming evidence that the model is doing much better. So independence is not an adequate model. Okay, so soundly rejected, sound rejection for the null hypothesis, and we could still look at AIC and BIC to compare model, which is what we'll be looking at in the next video.